Okay, so this is week 6. Okay, a little bit of a kind of catch up week. We appreciate you're maybe a week or so behind or so. Try and get there, but eventually you need to move away from the lab type stuff towards what's going to happen in the tests. Okay, so make sure that you maybe wrap up the lab and you're quite happy with what we're doing, and then move much more on to the test questions that are coming up in week 9. Okay, still got 3 weeks. Test goes ahead. It's done on Moodle. It's an open book test, so take along all your books and don't trust Google, honestly. Don't think you can go in there and Google for anything. I promise that the questions aren't asked like that. Okay, so today in the lab, we'll do a little bit of a integration thing. There'll be a bit of hashing, a bit of symmetric key, a bit of public key. You'll be able to get your phones out and see who's got the best phone here. iPhones, actually, are better at crypto than Android, but we'll see. I mean, generally, there's a good mass. Maybe we could try it now. I don't know if that's possible for you to quickly go to this web page. I think it's that web page. It's going to work. Good. So our security site, encryption JS12. If you just open it up on your favorite browser. Okay, have you got your favorite browser? Favorite Safari, Chrome, Firefox? Internet Explorer used to be terrible. Oh my goodness! But I think Edge is maybe better now with its crypto. Everybody there? Okay, so if you press on RSA, so this is done in JavaScript. Okay, so this is running in the browser that we have. Okay, there's no backend here. This is who would have believed in the 21st century that JavaScript would be used for anything as complex as this? Okay, are you all there? Are you all there? Right then, see who's got the best phone in the house. Okay, press on RSA encryption. That's not working. Have I crashed the server? No. Okay, so my key was generated in 241 milliseconds, 0.2 of a second for my 1K RSA key. Can you tell me what you're getting here for this value? 132. What have you got? Some sort of GPU? What was it? iPhone? XL 10? 10?
XL, yeah, 10.
Wow, that should wipe the floor with anybody. Anybody getting?
6, 7, 8.
6? What have you got? Some sort of ZX Spectrum or something? You got the same? 600.
1500.
You're joking.
It's like 4 years old.
Let me see your phone.
It's an old.
It's not Windows. It's not a Windows OS, is it? No. What are you getting there? Well, that's shocking. Anyone else? What are you getting? What? It's pretty good. So it's beating my browser. So people think that a browser on a laptop is faster. These phones are super fast. Anybody better?
50.
What? 50. Does that beat yours? 50. What have you got?
Pixel.
A Pixel. Google Pixel. Of course. Can I swap my phone with yours?
It's a small one.
Okay, so I've got a Samsung. Everybody else got a Samsung 9? Everybody got a Samsung 10? You got a Samsung 10? What are you getting for it then? It's pretty slow. Okay, now we'll get some smoke coming out of your phone. I go for a 2K key. A 2K key. See what you get for a 2K key. Oh boy. Just crank it, keep cranking it. So I got 3 seconds. 3 seconds for a key pair in RSA. Anybody better than that?
1289.
What is it?
12.
1.2 seconds, is that roughly? Pretty good. Anybody less than a second? 5?
68.
5, 6, 8. Half a second. So what is it you've got? An iPhone 7. God, that's unbelievable. And what browser are you using?
Safari.
I was just going to say that. Safari is very fast, quite optimized. Anybody else less than a second for that one? Okay, so we just saw Will talking about elliptic curve and how wonderful it is. If I'm an IoT device, that's just crazy. If I'm a little sensor sitting at the edge of your network, then 3 seconds becomes, I don't know, it could be a year, something like that. Okay, so let's go and see if we can see how elliptic curve is going to do. Okay, so my elliptic curve, 128-bit, which is equivalent to about 1K key or so. 39 milliseconds. What are you getting there? Anybody less than that? 27? Isn't it great that we're kind of getting about that? 32? See, that's great because it's all much the same, no matter what we're actually using. And remember what happened when we jumped 27. That's super fast. 19. We got 19. 18. What have you got? Some sort of Z series IBM? iPhone 10. Anybody else got an iPhone 10? They can check that. iPhone 10 is super fast. Super fast. I mean, Apple are pretty good at crypto, actually. This MacBook is a lot more secure than your Windows laptop, I hate to say. They have what's called a secure enclave, and not even Apple can get into that. When I shut the lid, you will not get access to the microphone for it, and people can not listen to you because of that secure enclave. Apple cannot get your crypto keys, which means you're kind of stuffed if it gets corrupt and things like that, but who cares? Okay, so if I go for the Bitcoin method, so we'll find Bitcoin uses SEPT 256K1. Don't ask me why they selected that one. It was probably because NIST were accused of putting backdoors in the elliptic curve method, so nobody uses the P256. They use these ones. So if we try this one, look at that. 60 milliseconds is 40. And what is it you've got? You've got an iPhone 7.
No, iPhone XR.
Is a 10. So you've got the 10, the iPhone 10 is winning, and the Pixel is winning. Anyone else got less than that? No, what are you getting?
166.
For the elliptic curve one. Oof. But it's still pretty low when you think about it compared to the RSA and there. Okay, so that's the wonderment of elliptic curve, is that RSA, goodbye. Elliptic curve, hello. Quantum computers, goodbye. Again. Okay, so today, I don't know, we can build this up. You can do some of your old labs and things like that. I've given you the code here in HTML. In crypto, always make sure you check everything. You check hello as an MD5 with OpenSSL, and you might check it with your own application, or you might check it with Python or Node.js. Don't ever assume that everything is working perfectly because OpenSSL is the definitive truth. Whatever the output, that's what the hash should be. It only got to version 1.1, I think. It's never grown up. It's a little kid. It was 0 point something for a long time. So OpenSSL is your little calculator to check everything. Okay, so I've got hashing methods here, block encryption, stream encryption, some HMAC. If you remember, HMAC is a bit like hashing, but there's a password or a key that goes along with it in there. And then I've got our public key methods in there. So if you want to do that in the lab, then that's fine. And I've shown you how to do it, hopefully, with with OpenSSL. So use the same You should get the same value when you create it. Okay, so that's for the lab today. See how you get on with that. JavaScript has the advantage of encrypting at the source. If you want to protect someone's password, then encrypt it in the browser and send it back. So no matter if someone's listening on the wire or at the other end, it's encrypted. If you always can, don't rely on tunnels, encrypt the data right at its source. Whenever you grab the data, encrypt it, and then you can send it through. In fact, I hate to say it, we don't need TLS in that world. We could encrypt everything at its source. Okay, so we're 3 weeks off. I think I've asked all of you on Slack how you getting on. So just say hello, everything's fine, or help. Okay, I'll give you feedback after the first test, so you'll know how you're getting on and things like that for there. Just do as well as you can, okay? And then we'll give you feedback. You get words into that little box and just try to really say as much as you can, but pace yourself. Okay, so we're going to be focusing on the tests quite soon, and just let me show you. So you should be able to view these, and I'll update them, okay? I think on Slack I've updated a Git update. I think if you look down, you'll see whenever I push anything new. So you should be able to check what I've actually added from there. But if you just scroll down, and if you go to assessments, and there are our 3 assessments. I'll go over the first test with you, and we can discuss, and then I'll go over the coursework after. Is that okay? Don't worry about test 2 just now. I'll explain that more later. Does that seem okay for that? Yep, good. Okay, so for the first test, it's open book test, 13th of March, and nothing is changing that date just now. It's done over Moodle. It's short essay type questions, descriptive. You can use any tools that you want, any books that you want, any online material, and so on. But I advise you to have all your pre-prepared sort of answers and things like that. But don't assume that you can just go in and just repeat a lot of it. So there's 4 areas that we'll be covering for it, and it takes us through the first 4 units: symmetric key, hashing, public key, and key exchange. Okay, those are the 4 questions that you'll actually get. And look at the questions. The questions are Bob has fallen out with Alice, and blah, 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 blah. That's the way that we ask them, okay? You're trying to make sense, you're trying to read the story and so on, and understand somebody says this and somebody else has said that over a coffee room break and stuff like that. Somebody's got upset and thinks that this is the wrong hashing method to use, okay? Just get over that and read the question, every single word, one at a time. Often, when you do this, you answer the question and, oh, there's a little question at the end that you just forgot about. So make sure you read the question, take your time, read it. I'm the world's worst. I have an eye that just goes bang. That's it, they're talking about Diffie-Hellman. I'm really bad for actually reading anything. So just try and read the question slowly and write down what you think it is, okay? Even if you interpret it wrong, then that's okay. I'll understand what you've said. If you have no clue of what's asked, you go, I have no clue. But here's what I think about something else that's kind of related to it. You know, like politicians do that, they get asked a question, and I do it all the time. Sorry, when I go on the TV or the radio, I've already got my pre-prepared. So no matter what they ask me, I just go, well, there you go. There you go. That's what politicians do, and they just keep doing that. So learn how to do that, but try and answer it if you can. Okay, Bob is using a 128-bit encryption key. Explain why the key space is unlikely to be, that should be 2 to the power 128, and why the key entropy could be used as a measured for the equivalent key space. Okay, that's a kind of simple one, kind of standard thing. We're using 2 to the power 128. Lots of keys, going to take the whole planet, energy of the whole planet and more to crack one key. But Bob's using QWERTY 123. We're stuffed. Okay, so we use a key derivation function. We're only dipping from a pool of about 8,000 words, and maybe he puts a number at the end, and so on. Hashcat knows all that kind of thing. Maybe have a look at some of the Hashcat rules that might help you with that kind of question and explaining it. But really, you're just trying to explain that we have all those keys, but Bob is only using those keys. So he's kind of stuffed and then. Okay, so try and read each of these questions and come up with your own answers in there. I've got a little fake questions in there too. So you might want to print this out and just write your little answers in here. Okay, maybe do it, actually write them out from there. Please also practice your typing. You don't want to be lagging behind your brain. I know that happens. It does in my case. So just make sure that you're typing fast enough to get the stuff in there if you can. Okay. So I've got some fake questions there that you can go and have a look, and please ask if you've got any queries. Try to do it on Slack one-to-one. Just say, Bill, I don't understand what you mean by 200 phrases. I think it's this. Is that right? And I will get back to you eventually. Please avoid email if possible. I get swamped with the emails, so Slack is much better for me. And obviously, just I'm around on campus, so there's no problem if you have to ask in the lab or in the lecture or in one of our sessions. Okay, oh yeah. Okay, so there's the sample questions there. Okay, there's often no right answer. Oh, that's scary. What do you mean no right answer? Well, there's a bit of this and a bit of that, and if you come up with a really wacky thing that might kind of work and stuff like that. If you get your keys around the wrong way, that we're human. If you say that you give me your private key, then I go, oh. But if your narrative kind of shows that you've actually it's just a wee typo and stuff like that, try and get the fundamentals right. Never give away your private key. You do know that, so don't write that. That rings alarm bells to me. So try and write something and get some sort of narrative up, and you'll get some marks. Okay, you're kind of looking, if the question's not working out for you, try and get half marks at least, or a little bit below, and you're not crashing. Okay, a lot of this is pacing yourself. You get an AES question, you go, yes, back in the net, I know all about this. I go, blah, 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 blah. And it's worth 3 marks. And the next question is worth 30 marks. And, oh, God, I've never seen that. Okay? Oh, that's what happens. If you don't do that 30, it's going to ring a big alarm bell. Yeah. So what's that? Okay? Pace yourself. You know, we do things sequentially. You go, question 1, okay. And then there's question 4 down here. It's going, answer me, answer me, answer me. I'm the best question possible. So don't assume that we'll do that easy. Each question will start off a bit easy, okay? Again, get a bit hard. And there'll be this thing in the tail, the horrible little bit at the end of the question that's really quite difficult. So make sure, you might leave this thing in the tail. Oh, that's too difficult. I'm going on to question 2 now. Do question 4 first. Question 4 is shouting out of you, I'm worth more marks than all of the other ones, for goodness sake. Answer me first. And if it's 1, 2 marks, just a sentence or 2. It's one thing that we're looking for. One little magic word might be the thing in there. If it's 10 marks, then it's 10 little things, roughly, that you're looking for in there. If you want to do bullet points, that's fine. Here's the answer, bang, 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 bang. There you go. Okay, does anybody have any questions? It's worth 30% of the overall module. 4, maybe 3 parts to each question. Easy, middle, sting in the tail.
I mean, the sub-questions.
3 in each. Roughly, if you could say 3 of those would make up 1 question. You have an hour and a half, so please try and practice with a timer. Go. I can assure you, an hour and a half is like 3 milliseconds. You go, what? What was that? What happened there? That was an hour and a half of your time. It is a crazy, you think you've got an hour and a half, but actually it goes in an instance. I don't know if you've ever sat this type of test. What? Keep an eye on the watch and just in case, and try and pace yourself from there. Did that answer your question? Any other questions? It's easy for me, isn't it?
Yeah. Online submission?
Yeah, it's on Moodle. I'll try and mark it quickly and get you some feedback, because I know that it matters to you. So I'll try and give you this quick feedback. It's a very big module overall. It might not seem that big here, but my goodness, it's even bigger with the online version. Okay, so right. Okay, so take your time and maybe just have a little look at that from there. So we're also going to start to look at, it depends how you want to do this. Most students will just wait to the last minute and do it. Okay, some students will do a little bit and then leave it for a while and come back to it. I'd advise you to be thinking about it. If there's an area you're really interested in, then grab a few papers and things like that. So what we want you to be as graduates of the future, basically, we've kind of mucked up. We've created this horrible internet that is completely untrusted. Virtually everything that we do on the internet, you cannot trust at all. So we really need to start to build for the future, and we hope our graduates will be the ones that will actually build the systems properly, that respect privacy and identity, and build a more trustworthy world. And there are also risks to the future. So what we've got as a coursework is something that you can pick your own topic. Okay, so someone might be working in a department in a company and they're worried about post-quantum crypto methods. So that's excellent, because if they're already working on it, the company wants to look at it and so on, this coursework might give an opportunity. Also, if you think you might want to be moving into a certain area when you graduate, it's a good opportunity if you go and meet a company, say it's a defense company, I won't say any of them, but you all know them, and you go, yeah, I know all about post-quantum crypto and things like that. Okay, so this will give you an opportunity to really do your own research. It's getting you set up for your dissertation. I hate to say it, but it's coming along sometime soon, and you'll have to get ready for it, okay? And if you can make it amazing, fantastic, brilliant, and you can publish a paper in a journal, my goodness, is that a great thing as an output to your MSc. It will exist, people will read it, people will change their minds on it. We have a great track record of our MSc graduates publishing their dissertation work in 3-star journals. I can show you a few examples of work from dissertations, and even, unbelievably, from this coursework. We got our first one that was published, that's just going to be presented in the next few weeks by Will, actually looking at privacy preserving machine learning type things. So it's got a good opportunity for you to really start to look, but maybe develop some skills in research. So the areas that we've defined, and these aren't the definitive list, the zero knowledge proof. Like it or not, we live in a world where we give away our data to everyone and their dog, and they use that data. So we need to move more. Why do I have to keep putting in my passwords? Why can't I just prove that I know my passwords? I've proved to you before, so why, Google, do I have to actually prove to you again that here's my passwords? Give me a little puzzle. Give me a little puzzle to solve and I'll solve it for you because I know my password. Anyone else, it's too difficult a puzzle. So zero knowledge proofs is really happening now, and really a lot of the complexity and the problems caused by it are really receding. So if you wanted to look at zero knowledge proofs, then that's a good area for you. There is code around. Then a really exciting area is what's called homomorphic encryption. Will it be possible in the future to encrypt my data? Say it's my tax return, and I could take your tax returns, I could add them all together, and I could actually find what the result is without actually revealing what my tax return is there. I can hold the encryption key so that you can actually find it. And it's happened with Zcash and Monero. So a big problem, as we'll find when we look at Bitcoin, is does Bob have enough Bitcoins in his account to pay Alice? The miners have 10 minutes to make that decision. Come on, 10 minutes. Has he got enough? Oh, just check. Yeah, he's got 15 Bitcoins, he's paying her 12. That transaction goes ahead. But if the transaction's 20 Bitcoins, then the miners say, go and get stuffed. No way can this transaction happen. He doesn't have enough Bitcoins in there. And the problem with Bitcoin is that you can reveal. I need to show you this Ethereum paper. Somebody has went and discovered, if you've got lots of money in Ethereum, anyone here got lots of Ethereum? No, because you wouldn't be here, that's for sure. If you had $1 million Ether, you wouldn't be here, okay? You'd be teaching. No, not quite, no, that's and somebody has mapped all the people who have got lots of money on Ethereum. So if you know anybody, because Ethereum isn't anonymized, anybody can actually, if they find your ID, they can trace all your transactions. Same with Bitcoin and so on. And it's only Zcash and Monero that actually, but it spooks law enforcement like anything. So obviously Bitcoin and Ethereum are used by bad people to launder money and so on. So law enforcement will try to graph. Whenever there's a ransomware paid, they'll go to the account. And you know what happens? If they watch an account, do you know what typically happens? What would be a timeline? think like Eve. Okay, so I've just had my Bitcoin ransomware reward paid. Yeah. What do you think happens next? Was it? Cash out. Yeah, ka-chink. Kinda, but I don't cash out because somebody's watching the exchange. You go, oh yeah, you just cashed out $1 million there. You wouldn't do that. What do they typically do? Yeah, they go typically a 1 to 4, 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 and then it'll probably all go back eventually into this bigger. You actually do it. There's really great graphs that you can that you can plot. If you're ever interested, there's really amazing trees that you can build up. This is somebody money laundering. Every 10 minutes, moves. I know they must be scripting it in some way because you wouldn't be able to get the hex IDs in fast enough. So they know the money's coming in, the money then needs to be laundered. It gets split and split and split, and then goes back into maybe a bigger account. They then move it from Bitcoin into Monero, and then they might move it to Zcash, and then eventually it's off. That tracing, I tell you, if you want to create a product that will sell in the market, there's one for you. That whole traceability, ransomware increases all the time. What happens? And you can sit and watch the ransomware accounts all the time and watch the money that's going in and who's paying the ransom and so on, and then how it gets laundered. You do know that Bitcoin reached 10K? Wow. It was about 7K just a few weeks ago, but it fell by a 1K. So it's a kind of moving target. Okay, so homomorphic encryption is a way that you can actually start to encrypt. There are standard libraries around. You can use the Microsoft one. Some of our students in the past have used Microsoft Seal as one, but it doesn't have to be as complicated as that. It could be a really simple example. Then there is there's lightweight crypto. Lightweight crypto is that AES is just too complex for an IoT device. So NIST is now looking at a short list of methods which will reduce CPU and especially reduce the drain on the battery that we have. Then, as I said before, quantum computers are coming along, and there's a whole lot of work going into post-quantum crypto methods. Eventually, elliptic curve and RSA will have to leave, maybe in a decade or so. Eventually, they'll be aged out. Even within 5 years, they might be pushed away because the risk is too much within 5 years that they might be deprecated. So you can look at that. As we saw last week, it's a very complex issue, key management and so on. So key distribution centers, Kerberos is one that you might want to look at, is a big issue. I know a lot of companies are looking at this and how you scale to a large scale network. And then there's anything to do with blockchain. If you wanted to get into Hyperledger, we have teams here that can give you, we'll look at Docker a little bit later, but one of the students here, PhD students, last year built a whole Docker infrastructure with Kubernetes, with Hyperledger, and he actually built a little ecosystem. So it doesn't have to be complex, or it can be complex. It really is up to yourself. So at the core of it is really a lit review. So it's really looking at Google Scholar, typically. So if we picked off, give me a topic that's related. Give me a topic. Anything you want? Maybe one from there? One from the list? Would you like, just name one? We'll go for lightweight crypto. Okay, that's what a lot of people go for. It's quite good, lightweight crypto. Okay, so there you are. Okay, so you go, how can I read this? Well, if you only want the recent papers, then we'll just organize it there. So here is where you look. Look, yeah, that's okay. 98. Whoa. Back of the net. That's a cracking paper. Well, it's actually a NIST report, but it's here. Okay, so whenever there's a gap here, you might have problems. You'll have to go and use the IEEE access things. I think it works on your IP address, so you'll be okay. So if you're missing a paper, then there's nothing wrong with just emailing the authors, finding their self-archive. So ResearchGate is a good place that you'll find a lot of self-archive papers. Google Scholar normally finds them. Oh, good. Oh, there we go. Wow. Yeah. that's the paper that you want. So if you really want to see a kind of good core paper, look at its citations and look at the time that it was published. Something that's got a high citation count looks to be a good paper. Paper that's not been cited at all in the last 10 years, something not quite right about it, it has no impact. The way I would do this is that I would very quickly, if you're doing it, say, in words and so on, at least you can copy and paste it into there. We prefer IEEE format, which is the numbers, like square brackets 1 and so on, IEEE format. But you can use APA or whatever you want, okay? You can do it manually, but as you move to your dissertation, please try to do this more dynamically and that you just create your bib and then you can reference in all of your things. Because our dissertation is 80 pages, you just need one reference and you'll muck up stuff and it might get seen. The way I would do it, and I appreciate that I write papers all the time, I would grab the bib of this, and then I would paste that in. The bib source is all you need, and some packages will allow you to be able to format that as required. Okay, then produce a prototype. It's just, there's lots of Git repositories. If you need a hand, just give us a shout. Python ones are easiest, Node.js, C++, make files and all that kind of thing. If you're using your Ubuntu, then I think they're pretty much good to go. CMake, ... make, bang, you've got your executable, okay? So you don't have to modify the code or write it yourself or so on. Just download it, see if you can get it to work, understand a little bit of it, and so on. Okay, so a little prototype, maybe looking at a lightweight crypto method. Then we want you to be able to evaluate it by running it, just like I showed you there. I want to run it with different key sizes or something else. I could do a little prototype of that, run it, and then get some measurements. Okay, so that's the last little bit in there. The basic structure, if you want a structure to it: introduction, lit review, implementation, evaluation, and then conclusions. The marking schedule is the quality of your research undertaken. Are you using good sources of references? Are they well defined, and so on? 20% of the marks for that. The quality and clarity of your implementation. If you do manage to produce a little bit of your own code, then that's great. If you're just taking standard code, then maybe not so good from there. Level of innovation. If you've got a wacky idea or something that you think is slightly new or maybe slightly different, you'll get some marks for that in there. Quality of the evaluation, or what you've actually created, and then your overall presentation. If possible, we would like it done in LaTeX, but it's your call. Okay, you can do it in Word if you want, if you're happy with that. We just use LaTeX with Overleaf all the time. The advantage with Overleaf is that you can send me a link to your Overleaf. I can review it, I can add comments, and so on. If you get stuck, it's worth the effort if you can get into LaTeX. I can assure you, if you want a beautifully looking dissertation that just doesn't require a lot of work to build and so on, then LaTeX and Overleaf. So we use Overleaf here, and in Overleaf you can either get it in your rich text format. It's not quite rich text, but in here you can either edit it in that. It's not Word, that's for sure. You try to do anything a bit more complicated in Word, and like equations and so on, and you'll find it's a pain. Okay, so this is the kind of thing that you get. You compile it, and you might produce a paper like this. Okay, as an example from last year, from there. And it's really up to yourself if you want to use this. From there, you can see the system has put the references in that IEEE format. But with LaTeX, if you want APA, then it's just a matter of kind of changing something in there. And here, I just change that, and I can have APA type format. But there's no reason you don't have to do it like this. The submission is a PDF document, so it doesn't really matter if it's a Word document you create it by or you use it in LaTeX. Does anybody have any questions on that? We'll go over it in more detail. Nope, I've got 5% battery, so hopefully we can get that. So I've got a little video that you can watch. I won't play it back just now, but it should go over what's in the coursework. Okay, we have a long time before it's actually submitted. One area that you might want to add is something to do with machine learning. Like it or not, the world of cybersecurity is moving towards ML at the front end because we're swamped. There's something like billions of alerts. If you have even a small company, there's billions of alerts. So increasingly we need machine learning at the front end. Splunk, for example, integrates a machine learning component with Python. So it will use standard methods. And there, if you want to learn a little bit of machine learning and a little bit of crypto, you might want to look at things like anonymized machine learning. But please don't just think that those are the areas. These are the areas that we think are exciting, and we can support you because we have research in each of these areas. And if you're ever struggling, there's always someone in the research group that will help you out. Any questions at all? I appreciate that I've rambled for the last hour or so. Does anybody have any? Please ask questions now about this. We have a while before it. Yeah.
Do you have like a template for the overview?
Yeah. So I'll share a template for you. And the great thing with LaTeX is that I want a different format. I basically just have to change that one line there, and I can have a lovely double column one. So we like it because we can produce research papers that will match to the requirements of the conference. So I'll get you that. These are just some examples here. I think this is the one that we've just managed to publish at an international conference, and that this was a student who did this coursework last year. I mean, this is about as good as you'll get. It's just gone a bit slow there. But the good thing with LaTeX is that you output it straight into a PDF format, so I can download the PDF once it's compiled from there. If you can produce your own GitHub repository, then that's really great. So you can maybe point to it and say, here is all my documents and my papers and things like that. Try to get used to using Git if you can. But this was a paper from last year based on the work done in the module. So I think it's the first time we've managed to publish inside our coursework. Obviously, we have higher level papers that are done through the dissertation instead. Any other questions at all? Good. Right. Okay. I've got a register. So you need to make sure you sign that now. But at 11 we'll do our little mini project, or you can catch up on any lab that you've done before, or you can talk about your dissertation or your coursework. or you can talk about anything else. Okay, right. Thanks very much, and see you in the lab.